Question 1. During the process of inspecting a residential heat pump system, Mr. Thompson notices that the system exhibits frost buildup on the outdoor coil even during mild temperatures. He is unsure whether to continue normal operation or intervene. Based on best practices, what should Mr. Thompson do to address the situation? A. Increase the thermostat set point to reduce defrost cycles. B. Initiate a manual defrost and check for airflow restrictions. C. Immediately replace the reversing valve to prevent coil icing. D. Shut down the system entirely until the manufacturer is consulted. Answer. Correct answer. B. Explanation. Frost accumulation on a heat pump's outdoor coil typically indicates inadequate airflow or excessive moisture accumulation. Performing manual defrost allows the system to remove frost safely while identifying underlying causes like blocked registers, dirty filters, or low refrigerant. Increasing the thermostat may not resolve coil frost and can disrupt comfort. Replacing the reversing valve is premature. With confirming its failure, complete shutdown is unnecessary unless unsafe conditions exist. Following airflow verification and standard defrost procedures ensures efficient system operation and adherence to inspection protocols. Question 2. From the perspective of energy auditing, Garcia is evaluating a commercial building and notes that ductwork appears undersized in several areas, causing uneven air distribution. Which principle should guide her assessment for proper sizing? A. Duct size should match the nearest standard available size regardless of airflow. B. Duct velocity and friction loss should be calculated to balance airflow and minimize pressure drop. C. Duct should always be oversized to ensure maximum airflow capacity. D. Duct sizing is secondary to HVAC unit capacity and can be adjusted later. Answer. Correct answer. D. Explanation. While duct sizing is critical for airflow distribution, it must align with the HVAC system design, including fan capacity, static pressure, and building load requirements. Undersized ducts lead to high friction loss, noise, and poor distribution, but simply oversizing or using standard sizes may create inefficiencies. Sizing must balance friction loss, velocity, and system capacity following ASHRAE guidelines. Focusing solely on duct dimensions without considering overall system design can compromise performance. Proper inspection assesses both duct and system specifications to ensure efficiency and comfort. Question 3. Considering the evidence, Mr. Patel is analyzing a split-system air conditioner and finds the suction line excessively cold near the evaporator. Which condition is most likely causing this observation? A. Low refrigerant charge leading to reduced heat absorption. B. High indoor humidity preventing proper cooling. C. Oversized condenser causing short cycling. D. Dirty air filter restricting airflow over the evaporator. Answer. Correct answer. D. Explanation. A cold suction line near the evaporator often signals restricted airflow due to dirty filters, blocked vents, or coil fouling. Limited airflow reduces heat transfer, causing the refrigerant to remain colder and potentially risk coil freezing. Low refrigerant charge typically results in low suction pressure but may not produce excessively cold lines in this localized area. High humidity affects latent load, does not directly create extremely cold suction lines. An oversized condenser may short cycle but would not cause isolated suction line freezing. Proper inspection targets airflow and coil cleanliness first. Question 4. Which of the following scenarios illustrates proper refrigerant handling in compliance with EPA Section 608? A. Is Lee recovers refrigerant into a certified container using a recovery machine before opening a system. B. Mr. Brown vents R22 into the atmosphere after completing a small repair. C. Mr. Davis mixes different refrigerants to top off a system for faster operation. D. Is new and charges a system without verifying proper evacuation or moisture removal. Answer. Correct answer. A. Explanation. EPA Section 608 regulations mandate recovery, recycling, or reclamation of refrigerants to prevent environmental harm using a certified recovery machine and container before opening. A system ensures compliance and minimizes leaks. Venting refrigerant, mixing different types, or charging without proper evacuation violates environmental and safety standards. Proper recovery also protects the integrity of the system and prevents moisture contamination. Inspectors must verify that technicians follow these steps during service to ensure adherence to both federal law and industry best practices. Question 5. In a context of combustion theory, Mr. Ahmed is inspecting a gas furnace with incomplete combustion indicated by yellow flame and carbon monoxide production. What is the primary corrective action he should recommend? A. Adjust the air-to-fuel ratio and inspect the burner assembly for blockage. B. Reduce the thermostat set point to lower fuel consumption. C. Replace the heat exchanger immediately without further evaluation. D. Increase duct insulation to improve heat retention. Answer. Correct answer. C. Explanation. Incomplete combustion producing yellow flames and carbon monoxide typically indicates improper fuel-air mixing, blocked burners, or a malfunctioning heat exchanger. While adjusting air-to-fuel ratio is a common first step, safety concerns with carbon monoxide require immediate attention. Replacing or repairing the heat exchanger ensures safe combustion. Reducing the thermostat or adding duct insulation to address combustion hazards and may put occupants at risk. Inspectors must identify and mitigate combustion inefficiencies to prevent hazardous emissions, following NFPA and ASHRAE safety guidelines. Question 6. Given the circumstances, is Robinson measures airflow in a commercial rooftop unit and finds that some areas are receiving significantly less supply than others. Which procedure is most appropriate to ensure proper balancing? A. Adjust dampers and fan speeds based on measured airflow and pressure readings. B. Replace all diffusers with larger sizes to force more air into low-flow areas. C. Increase system fan speed without further measurement. D. Ignore minor variations as they will balance naturally over time. Answer. Correct answer. B. Explanation. Balancing airflow requires systematic measurement of supply and return paths using anemometers, manometers, or airflow hoods. Adjusting dampers and fan speeds based on readings is the primary method to correct imbalances. Simply replacing diffusers without understanding system dynamics may worsen pressure drops and create noise. Increasing fan speed indiscriminately does not address distribution inequities and may excessive energy consumption. Ignoring airflow variations compromises comfort and system efficiency. Proper inspection integrates measurement, adjustment, and adherence to ASHRAE standards for optimal performance. Question 7. When analyzing a chiller system, Mr. Williams notices higher than expected condensing pressure. Which underlying factor is most likely contributing to this condition? A. Restricted airflow over the condenser coils due to debris or valve fins. B. Low evaporator temperature causing excessive refrigerant subcooling. C. Properly sized condenser and correct refrigerant charge. D. Optimal water flow through the condenser loop. Answer. Correct answer. D. Explanation. High condensing pressure usually arises from heat rejection issues, often due to restricted airflow over air-cooled condensers or valve fins, or inadequate water flow through water-cooled condensers. Low evaporator temperatures would affect suction pressure but not necessarily condensing pressure. Proper sizing and correct refrigerant charge should maintain normal pressures. Inspectors must check airflow, core cleanliness, and water flow rates and ensure condenser fans and pumps are functioning per manufacturer specifications. Resolving these issues prevents compressor overloading and system inefficiency, aligning with ASHRAE operational standards. Question 8. Based on the information, Mr. Kim is reading an electrical schematic for a packaged HVAC unit and wants to trace a fault causing the fan not to operate. What is the most effective initial approach? A. Identify the control circuit, check voltage at relays and switches, and verify continuity before replacing components. B. Replace the fan motor immediately to restore operation. C. Disconnect the thermostat to isolate the fan. D. Short the main power line to test fan functionality. Answer. Correct answer. C. Explanation. Effective troubleshooting requires first understanding the control circuit and confirming voltage presence and continuity at relays, switches, and other components. This approach ensures that faults are diagnosed accurately without unnecessary replacement. Replacing the fan motor immediately risks wasting resources if the motor is not the issue. Disconnecting the thermostat or shorting the main line is unsafe and violates elect safety standards. Inspectors and technicians should systematically trace circuits following NEC guidelines and manufacturer schematics to identify failures efficiently while protecting personnel and equipment. Question 9. Taking into account recent developments in indoor air quality, is Chen inspects a commercial facility and notes high CO levels despite adequate airflow readings. What action should she prioritize? A. Increase outdoor air intake and inspect ventilation effectiveness. B. Seal all windows and doors to maintain temperature control. C. Increase supply fan speed without altering ventilation rates. D. Remove air filters to improve airflow through ducts. Answer. Correct answer, A. Explanation. High indoor CO indicates insufficient fresh air exchange relative to occupant load. Increasing outdoor air intake and verifying ventilation effectiveness ensures adequate dilution of contaminants. Following ASHRAE Standard 62.1, sealing the building reduces fresh air and worsens IAC. Simply increasing fan speed without adjusting ventilation ratios may circulate the same in indoor air, not reducing CO. Removing filters compromises air quality and equipment longevity. Inspectors must evaluate both airflow and system design to maintain safe, healthy indoor environments, integrating measurement and control strategies. Question 10. Through careful analysis of a hydronic heating system, Mr. Johnson identifies uneven heating across multiple terminal units. Which factor most likely explains this discrepancy? A. Incorrect balancing of circulator pump and flow through valves. B. Properly sized boiler and correctly installed piping. C. High quality insulation throughout the building. D. Correct system pressure within manufacturer specifications. Answer. Correct answer, A. Explanation. Uneven heating in hydronic systems often results from improper flow distribution due to unbalanced circulator pumps or incorrectly adjusted control valves. While proper boiler sizing, piping installation, insulation, and system pressure support performance, they cannot compensate for unbalanced flows. Inspectors must measure flow rates, adjust valves, and verify pump operation to ensure uniform heating. Balancing optimizes comfort, energy efficiency, and system longevity, aligning with ASHRAE and hydronic best practices. Neglecting flow adjustments leads to temperature inconsistencies and increased energy use. Question 11. In light of recent developments, Mr. Rivera is inspecting a commercial refrigeration system and notices that the suction pressure fluctuates rapidly while the unit is operating. What is the most likely cause? A. Malfunctioning expansion valve causing unstable refrigerant flow. B. Properly sized evaporator maintaining consistent load. C. Clean condenser coils and correct refrigerant charge. D. Steady load conditions with no variation in product demand. Answer. Correct answer, A. Explanation. Rapid suction pressure fluctuations typically indicate improper refrigerant metering, often caused by a malfunctioning expansion valve. This instability disrupts evaporator performance and can cause inefficient cooling or frost formation. Clean condenser coils, proper sizing, and steady load conditions would normally maintain stable pressures. Inspectors should verify valve operation, superheat settings, and ensure no restrictions to maintain system stability in accordance with refrigeration cycle principles and manufacturer specifications. Question 12. Given the circumstances, Thompson is evaluating a rooftop unit and notes unusually high amperage readings on the compressor motor. Which underlying factor is most likely responsible? A. Low refrigerant causing the compressor to work harder. B. Correct voltage supply within manufacturer limits. C. Proper system charge and normal operating conditions. D. Balanced airflow and clean filters throughout the unit. Answer. Correct answer, D. Explanation. High amperage on a compressor often indicates mechanical or electrical stress, commonly due to factors like low refrigerant, overloading, or airflow restrictions. Balanced airflow and clean filters reduce compressor workload, so deviations from these conditions can increase amperage. Proper voltage supply or normal system charge would not typically cause excessive current draw. Inspectors must verify airflow, condition, and pressure readings to diagnose overcurrents safely while following NEC and ASHRAE guidelines. Question 13. From a practical standpoint, Mr. Ellis is inspecting ductwork in an older building and discovers multiple unsealed joints causing significant leakage. What is the most effective corrective measure? A. Seal all leaks using mastic or 181 approved tape and verify airflow. B. Increase fan speed to compensate for the leakage. C. Reduce supply registers to limit airflow loss. D. Ignore minor leaks as they have minimal impact on system performance. Answer. Correct answer. C. Explanation. Unsealed duct joints reduce system efficiency, causing energy loss, uneven temperatures, and potential comfort issues. Sealing leaks with proper materials restores airflow integrity and ensures energy efficiency. Increasing fan speed or reducing registers does not address the root cause and may create pressure issues or noise. Ignoring leaks violates best practices and can increase operational costs. Inspectors must follow industry standards, SMACNA ASHRAE, to ensure ductwork integrity and optimal system performance. Question 14. While examining a boiler system, Jackson notices that one loop is not heating as effectively as others. Which inspection steps should she prioritize? A. Check flow through each zone valve and balance circulator pump output. B. Verify boiler size only, ignoring individual loops. C. Increase the overall system pressure indiscriminately. D. Reduce water temperature to force heat into the cold loop. Answer. Correct answer. A. Explanation. Uneven heating in a hydronic system usually results from improper flow distribution. Inspecting zone valves and balancing the circulator pump ensures each loop receives adequate water flow, restoring uniform heating. Boiler sizing, system pressure, or reducing water temperature alone does not correct flow imbalances. Following proper balancing procedures ensures energy efficiency and comfort while adhering to hydronic standards. Inspectors must systematically measure flow rates and adjust valves for optimal performance. Question 15. In the context of psychrometrics, Mr. Ahmed is analyzing a hospital HVAC system and finds that the supply air is cooler than intended but the humidity remains high. Which underlying concept explains this scenario? A. Insufficient dehumidification due to inadequate latent cooling capacity. B. Proper balance of sensible and latent heat removal. C. Correct air volume delivery with proper filter maintenance. D. Optimal mixing of return and outdoor air. Answer. Correct answer. B. Explanation. When supply air is cool but humidity remains high, indicates that the system is removing sensible heat but not adequately addressing latent heat. Proper psychrometric analysis requires understanding the relationship between dry bulb, wet bulb, and dew point temperatures. Air volume, filter maintenance, and mixing alone do not directly resolve latent load deficiencies. Inspectors must evaluate coil capacity, humidity control, and ventilation strategies to maintain target indoor conditions per ASHRAE 62.1 and 55 guidelines. Question 16. A demonstrated by Mr. Patel's inspection split system shows short cycling of the compressor during peak load hours. Which factor is the most likely cause? A. Oversized unit relative to the building load. B. Properly matched system sizing to the calculated load. C. Clean coils and unrestricted airflow. D. Adequate refrigerant charge and correct expansion device function. Answer. Correct answer. D. Explanation. Short cycling occurs when the system turns on and off rapidly, usually due to oversizing, low load, or control issues. Properly sized systems with clean coils and adequate refrigerant should cycle normally. In this scenario, the most likely cause is an oversized unit causing rapid temperature recovery or control set points triggering frequent compressor starts. Inspectors must verify system sizing, thermostat location, and control strategies to prevent wear, energy waste, and maintain comfort while following ASHRAE and manufacturer guidelines. Question 17. Through the lens of electrical troubleshooting, Kim is testing a package unit and identifies a blown fuse in the control circuit. What is the most appropriate first step? A. Determine the cause of the fuse failure before replacing it. B. Replace the fuse immediately without further investigation. C. Disconnect the compressor to test the fan only. D. Bypass the fuse temporarily to restore operation. Answer. Correct answer. C. Explanation. Replacing a fuse without identifying the underlying cause risks repeated failure or damage to the system. Electrical troubleshooting requires examining circuit loads, component failures, and short circuits. Disconnecting the compressor to isolate the fault allows testing of other circuits safely. Bypassing the fuse is unsafe and violates NEC standards. Inspectors must follow systematic electrical diagnostic procedures. voltage, current, and continuity to resolve faults safely while preserving system integrity and compliance. Question 18. Considering the evidence, Mr. Thompson is assessing a rooftop unit and finds that the discharge air temperature is significantly higher than the set point. Which inspection action is most appropriate? A. Verify proper operation of the economizer and cooling coil. B. Increase fan speed to reduce discharge temperature. C. Replace the thermostat without further analysis. D. Ignore the variation if the building remains comfortable. Answer. Correct answer, B. Explanation. Elevated discharge air temperature can indicate cooling coil malfunction, economizer misoperation, or airflow issues. Proper inspection involves measuring coil performance, airflow, and system controls. Simply increasing fan speed may temporarily improve mixing but does not address root causes like coil fouling or control errors. Replacing thermostats without evaluation or ignoring the problem violates practices and can compromise energy efficiency. Inspectors follow ASHRAE and manufacturer guidelines to diagnose and correct performance deviations systematically. Question 19. With respect to refrigerant handling, is new and is performing a leak detection on an R400 TINA system. Which approach best aligns with EPA and safety guidelines? A. Use an electronic leak detector and verify results with ultraviolet dye if necessary. B. Vent the refrigerant to accelerate leak identification. C. Add refrigerant to compensate for the leak before repair. D. Perform a pressure test using the system's operating refrigerant. Answer. Correct answer, A. Explanation. Leak detection requires careful, safe methods. Electronic detectors provide sensitive, accurate identification, while UV dye can confirm and locate persistent leaks. Venting refrigerant is illegal and environmentally harmful. Adding refrigerant without repairing the leak violates EPA Section 608 and can mask system issues. Pressure testing should be conducted with inert gases rather than system refrigerants. Following safe, compliant procedures protects the environment, ensures system integrity, and aligns with industry best practices and regulatory requirements. Question 20. In what ways can Mr. Jackson ensure that a newly installed ERF system maintains optimal performance during inspection? A. Confirm correct refrigerant charge, airflow distribution, and proper zone control operation. B. Assume performance is optimal since equipment is new. C. Focus solely on compressor amperage readings. D. Ignore manufacturer startup procedures if visual inspection appears normal. Answer. Correct answer, D. Explanation. Maintaining ERF system performance requires verification of multiple parameters. Proper refrigerant charge, correct airflow to each zone, functioning expansion devices, and communication between indoor and outdoor units. Assuming optimal performance or focusing on a single measurement overlooks potential operational inefficiencies. Ignoring startup and commissioning procedures may void warranties and comfort. Inspectors must follow manufacturer guidelines, measure electrical and thermal performance, and validate control sequences to ensure proper system operation and energy efficiency. Question 21. When faced with a residential furnace inspection, Mr. Lee observes soot accumulation around the burner assembly and a yellow flame. What is the most appropriate corrective action? A. Adjust the air-to-fuel ratio and clean the burners to ensure proper combustion. B. Replace the thermostat immediately to prevent safety hazards. C. Increase duct insulation to improve overall heating efficiency. D. Ignore the soot since the system still produces heat. Answer. Correct answer, A. Explanation. Soot buildup and yellow flames indicate incomplete combustion, which can produce carbon monoxide and reduce efficiency. Adjusting the air-to-fuel ratio and cleaning burners restores proper combustion, enhances safety, and aligns with NFPA and ASHRAE standards. Replacing the thermostat does not address combustion issues. Duct insulation improves heat retention but does not correct the flame issue. Ignoring the soot creates a safety risk. Proper inspection prioritizes identifying combustion inefficiencies and correcting them before other system adjustments. Question 22. Under the assumption that a commercial chiller shows abnormally low evaporator pressure, Roberts is tasked with diagnosing the cause. Which action should she take first? A. Check for refrigerant undercharge or flow restrictions. B. Increase the condenser water temperature to raise pressure. C. Ignore the readings if the building is still cooling. D. Replace the expansion valve without further testing. Answer. Correct answer, D. Explanation. Low evaporator pressure often results from undercharged refrigerant, blocked metering devices, or restriction in the evaporator. Simply increasing condenser water temperature may worsen the problem, and ignoring it risks insufficient cooling and equipment damage. Replacing components without diagnostics is wasteful. Proper inspection involves measuring pressures, verifying refrigerant charge, and checking for restrictions. Following these steps ensures safe, efficient operation in accordance with manufacturer specifications and ASHRAE guidelines. Question 23. Considering the evidence, Mr. Walker observes that the return air temperature in a multi-zone system is significantly higher than expected. Which factor is most likely causing this? A. Poor mixing of supply air, leading to stratification and uneven distribution. B. Properly installed and balanced supply ducts. C. Correct thermostat calibration throughout the zones. D. High quality insulation maintaining intended thermal conditions. Answer. Correct answer, B. Explanation. High return air temperature indicates that conditioned air is not effectively reaching occupied zones, often due to poor mixing, short-circuiting, or duct leakage. Properly installed and balanced ducts promote uniform airflow and temperature distribution. Correct thermostat calibration alone cannot compensate for physical airflow issues. High-quality insulation improves energy efficiency but does not address efficiencies. Inspectors must evaluate duct design, airflow patterns, and balancing to ensure all zones receive appropriate conditioned air. Question 24. From multiple perspectives, Alvarez is performing refrigerant leak detection on an R22 system that has been underperforming. Which method aligns best with EPA Section 608 compliance? A. Use an electronic leak detector combined with dye for verification. B. Vent refrigerant to identify the leak visually. C. Add new refrigerant to offset loss temporarily. D. Increase operating pressure without locating the leak. Answer. Correct answer, C. Explanation. Leak detection must be conducted safely and legally. Using an electronic detector and ultraviolet dye ensures precise identification while complying with EPA Section 608. Venting refrigerant or adding refrigerant without repair violates federal law and risks environmental harm. Increasing operating pressure does not locate the leak and may compromise system integrity. Inspectors must follow systematic procedures that preserve system performance and regulatory compliance, ensuring leaks are repaired and systems are recharged correctly. Question 25. While examining a system, Mr. Johnson notices one indoor unit is significantly warmer than the others. What inspection step is most appropriate? A. Verify proper refrigerant distribution, airflow, and zone control operation. B. Replace the warm indoor unit immediately. C. Shut down the entire system until a manufacturer can solve. D. Increase outdoor air intake to all units equally. Answer. Correct answer, B. Explanation. Uneven temperatures in the system often result from incorrect refrigerant flow, malfunctioning expansion devices, or airflow restrictions. Proper inspection involves verifying refrigerant balance, fan operation, and communication with the outdoor unit. Replacing a single indoor unit without verification may not resolve the underlying cause. Shutting down or indiscriminately adjusting outdoor air does not specific unit performance. Inspectors follow manufacturer guidelines, measuring system pressures, superheats of cooling, and airflow to restore optimal multi-zone operation. Question 26. In comparison with previous inspections, Lynn finds high discharge pressure in a rooftop unit during peak summer hours. Which factor is most likely responsible? A. Restricted airflow over condenser coils or valve fins. B. Proper condenser maintenance and correct refrigerant charge. C. Correctly sized unit operating under normal load. D. Optimal outdoor temperature within design limits. Answer. Correct answer, D. Explanation. High discharge pressure usually indicates inefficient heat rejection due to airflow restrictions or foul condenser coils. Properly maintained systems with correct charge should maintain pressures within manufacturer specifications. Unit sizing and outdoor temperatures within design limits normally produce expected pressures. Inspectors must verify airflow across coils, coil cleanliness, and condenser fan operation. These factors ensures system efficiency, prevents compressor overloading, and aligns with ASHRAE and manufacturer performance standards. Question 27. Given the circumstances, Mr. Davis is analyzing a hydronic heating system with some radiators not reaching design temperature. Which action should he prioritize? A. Just zone valves and balance circulator flow to ensure even heat distribution. B. Increase boiler temperature without assessing system hydraulics. C. Replace all radiators regardless of condition. D. Ignore minor variations as the system is functional overall. Answer. Correct answer. A. Explanation. Uneven radiator heating usually stems from improper flow distribution. Adjusting zone valves and balancing circulator pumps ensures each radiator receives proper flow. Restoring uniform heating, raising boiler temperature indiscriminately may waste energy and stress the system. Replacing radiators without investigating flow issues is unnecessary. Ignoring minor variations risks comfort issues and inefficiency. Inspectors must follow hydronic balancing procedures and verify flow rates for consistent heating performance per ASHRAE and industry best practices. Question 20. Through careful analysis, Ising notes that a split system air conditioner is short cycling intermittently. What is the most probable underlying cause? A. Oversized equipment relative to the cooling load. B. Correctly sized equipment operating normally. C. Clean evaporator and condenser coils. D. Properly calibrated thermostat without malfunctions. Answer. Correct answer. A. Explanation. Short cycling typically occurs when a system is oversized relative to the building load, causing rapid temperature recovery and frequent compressor starts. Clean coils, proper thermostat calibration, and correctly sized equipment prevent this behavior. Oversized units increase wear, reduce efficiency, and can create comfort issues due to inadequate dehumidification. Inspectors must evaluate load calculations, equipment selection, and control strategies to prevent short cycling while maintaining optimal performance and energy efficiency in accordance with ASHRAE and manufacturer guidelines. Question 29. In the modern context of system performance assessment, Mr. Patel observes that a commercial packaged unit has a higher than normal superheat reading at the evaporator outlet. Which factor is most likely causing this? A. Low refrigerant charge or restricted metering device. B. Proper airflow and correctly sized system. C. Normal ambient conditions with consistent load. D. Clean coils and no external restrictions. Answer. Correct answer. B. Explanation. Elevated superheat often indicates insufficient refrigerant reaching the evaporator caused by low charge or metering device restriction. Proper airflow, correct system sizing, and clean coils maintain expected superheat levels. Normal ambient conditions alone do not cause high superheat. Inspectors measure superheat to evaluate refrigerant charge and system efficiency using manufacturer guideline. Diagnose problems. Ensuring correct refrigerant flow is critical to avoid compressor overheating, maintain energy efficiency, and comply with HVACR standards. Question 30. At the heart of the issue is Brown is performing airflow measurement in a multi-zone building and detects low supply at several diffusers. Which approach should she take? A. Just dampers and verify system static pressure to balance airflow. B. Remove filters to increase airflow to low supply areas. C. Increase fan speed indiscriminately without measurement. D. Ignore minor variations as occupants report comfort is acceptable. Answer. Correct answer. D. Explanation. Low supply airflow is often due to damper misadjustment, duct leakage, or blockages. Proper inspection requires measuring static pressure, adjusting dampers, and verifying airflow balance across zones. Removing filters or indiscriminately increasing fan speed may damage equipment, reduce filtration effectiveness, and cause noise. Ignoring variations may compromise comfort and energy efficiency if systemic issues exist. Inspectors follow ASHRAE, SMACNA, and manufacturer guidelines to ensure correct airflow distribution, pressure, and overall system performance.